Hi Bella, how are you doing? Oh, also, can you hear me properly and everything today? Oh, good. I'm guessing the fact you replied means you can hear me as well. Hi, Yunga. Hi, my tutor, I mean. So, yeah, I'm well, thank you, Bella. Thank you for asking. Loud and clear. Good. We're getting better at this, I think. Slowly getting used to it all. So, yeah, we'll just wait for a few people to join. We'll start at 5 past. We're going to be doing. Hi, Lila. Yeah, we're going to be doing some equations of circles today. Mainly just sort of looking at the equations, and then we'll look at some like exam questions on it. Yeah. Circles, really needed help with this topic as you're doing it currently. Oh, that's good to know. This is going to be helpful for you then. We're going to do a few lessons on circles. So today it's equations of circles. Next week is areas and circumferences of circles. And the week after it's sectors and arcs. So they're all self-contained, but if you're doing it at the moment, so you're aware there's going to be a few weeks of this. How do you all feel about like when you see questions of circles? A lot of people, it's a bit like, it's funny, some people really like shape questions, and some people really panic when they see them. Like the second they see like shapes, like circles or polygons in a question, they immediately think it's going to be really hard before they even get to doing the question. Everything except circle theorems. Okay, so circle theorems is the one that you panic on. I would like. I'm not doing that today. However, like if circle theorems is something you struggle with, when you go to learn it, don't learn the like descriptions of the rules. Instead, draw out the patterns because it's more pattern recognition than anything. So yeah, just get really used to like recognizing the patterns within the circles for things like that, and it will make it a lot easier. Can sometimes be confusing when there's not many numbers. Yeah, that's fair. That is fair. I guess I think the thing that makes shape questions trickier for a lot of people is that sometimes you have to divide it down into smaller shapes yourself and sort of figure out the whole plan yourself. Whereas for things like algebra, often it's quite clear where you're supposed to start first. So maybe that's like where some people can find it a bit trickier. Um, Generally, like if you can divide things down into either like squares and rectangles or triangles, like you do so much on triangles, so they're the shapes you're usually looking out for. um, okay, I think what we'll do is we'll just get started, and any stragglers who join, they can follow along as well. So first of all, if I can figure out what I'm doing again on the screen, so we go over here. Oh, it's really huge. Let me see if I can zoom out of it a little bit. Okay, so this is your general equation of a circle. So x minus a all squared, y minus b all squared equals r squared. So this is something to learn. And the idea is that once you get an equation for a circle in this form, you can just read off where the center is and what the radius is. A little bit like if you have a straight line equation with your y equals mx plus c, once you get it into that form, you can just read off the gradient and y-intercept. So I'm going to first ask if anyone knows this, but for this general equation, what is your center of the circle? I'll give you a few seconds. If anyone knows, put it in the chat. But yeah, have a think about it. For this equation here, what would the center of this circle be? So, because there is a bit of a lag, I am going to answer it. So pi r squared. Oh, that is good. That's another circle equation. So pi r squared would be the area of the circle. The center of the circle. So by what we mean by the center is if we draw a circle over here, and imagine your circle being drawn on some x and y axes. And imagine that they're drawn nice and straight and perfectly, and not all wonky and shaky like they are. So here's our y-axis, and here's our x-axis. The center of the circle is if I draw a circle on here, so something like this, ish, then the center is just where the middle of the circle is. So it's like the middle point somewhere over here. And if you have an equation, so there's your center. So for this circle, it's not 0, 0. So a lot of the equations you will see, and for the most simple examples, it will just be 0, 0. And however, if you're reading it off the equation, the coordinates of that center are A, B. So the number with the x is the x coordinate of the center, and the number with the y is the y coordinates of the center. And you just flip the sign, a bit like when you're solving quadratics, you switch the sign over. So you can just read that off your equation for a circle. And then what is the radius then? So if A and B are the center of the circle, what's the radius of the circle, do you think? And there's a little bit of a clue in like what I've chosen as the letters here. So that's the center, and therefore the radius is what? Again, I'll let you have a little bit of a think about it. So for this one, it's the number on the end that everything equals, but square rooted. So r squared means just the radius squared. So again, when it's in this format, you can take A as your x coordinate of the center, B as the y coordinate of the center, and the square root of the number on the end as the radius. Yeah, no, that's good. So that's what we're going to be using today. And once you learn those, and once you know those once you know those by heart, these questions become a lot easier, because a lot of the questions, and they can be quite a few marks, are just reading off the values from the equation. So the radius is the square root of the number on the end, or in other words, just r. So we'll have a look at a few examples of this. First of all, I'm just going to look at some examples of equations of the circles. Quite awkwardly sized this. Let's try and move it all over again. Okay. So if I have an equation that is x plus 4 all squared plus y minus 1 all squared equals 36, does anyone know what the coordinates for the center of this circle would be? And then also after that, I'm going to ask you what the radius is as well. So if anyone wants to have a go in the chat of just reading it off of the equation. So the center, you're going to look at the numbers inside the brackets with the x and y. And that will be your x coordinate and y coordinate. And the radius, you want to look at the number on the end. So minus 4, 1, perfect, Finn, that's completely right. That's the coordinates for the center. So minus 4, 1. So I'm just taking the numbers on the inside, switching the signs. And then everyone's right. The radius is going to be the square root of the number at the end, which here is just going to be 6. Okay, good. So we'll do one more example of this, and then we'll have a look at some exam questions on it. So how do I get this to... Wow, I wish I was better at technology. Oh, there we go. Okay, so then how about if I have x squared plus y minus a half all squared equals 16. What grade is this? So these are often on higher papers, but I believe they can be foundation as well. You might have to check for your syllabus. These questions we're doing right now, they're the easier end of the questions. And we're going to have a look at some that are progressively harder. So -1 and 0.5. And r is 4. Okay, one of your coordinates is correct, the other one is not. Which one, does anyone have any ideas about which one might be different to -1? Aaron, 0. Perfect, yeah, between you, you've perfectly got it. So over here, we have x squared on its own. So there's no numbers in the brackets with it. So this is a little bit like if you imagine there's an imaginary 0 in there with it. I've basically added 0 onto the x and squared it. So whenever I just have the letter on its own, the coordinate for that letter is 0 in the center. So for this one here, the center would be 0 and a half. So again, taking the one with the y, flipping the sign, and just like you said, Finn, the radius for this would be 4, because that's going to be the square root of 16, which will be 4. So bear that in mind, take that. We're going to now look at some exam questions and apply this. Also, if anyone has any questions, as always, just put it in the chat. I will look and try and answer any questions anyone has. So this is quite a typical question. So construct the graph of x squared plus y squared equals 144. So this is just like the ones before. To be able to construct the graph, we need to know where the key points are. So in other words, we need to know the coordinates of the center, and that's always a good place to start with. So we first want to figure out where the center is. And if anyone wants to have a go at like putting those into the chat. And we also need to know what the radius is. Yep, good. So the radius is 12. So square root of 144, which is 12. And how about the center? 0, 0. Good, yeah. Okay, good. So we've got what the center of the circle is, and we have what the radius of the circle is. So now we just want to put the graph together. So for any graph, sometimes they will give you the axes, but we're just going to sketch it. So roughly draw the graph, do our own axes. So we're going to have our y-axis up here and our x-axis over here. So we've just said that the center of our circle, let's change to color. So we said the center of our circle is at 0, 0. And then we've also said that the radius is going to be 12, which means if we go from the center outwards to the edge of our circle in any direction, that length will be 12. So it's probably easiest to just focus on going vertically upwards or horizontally across. So this is actually going to cross the axis up here at 12, over here at -12, and then we can connect them up. It's not a very well drawn circle, but you kind of get the point. And then you would just sort of label your coordinates of the center over here. So yeah, so that's our idea for constructing graphs. Let's have a go at another one of these. zoom out again. So same idea over here. To be able to do this, we first off want to figure out the center of the circle and the radius of the circle. So for this one, what is our center going to be? Minus 2, 3. And perfect, yeah, you're all getting this completely right. So the center is here, and the radius is going to be 5. Perfect. So again, we would go and draw our axes. So we can put where our center of the circle is here. Oh, you can't really see that. So minus 2, 3. So that's going to be over here somewhere. And the radius is going to be 5, which means that we actually can also read off our y and x coordinates here too. Our y-intercept is going to be where x is 0, and our x-intercept will be where y is 0. So we could also work those out. However, like, I kind of think it's more useful to just kind of draw this on to start with. Depends really what this question, it's supposed to be centered around there, is asking you for. So let's try and make it look like it is actually the center. So the distance here will be 5. Just like for graphing, I can show you how you would find the x and y intercepts. So if I wanted to find the y-intercepts, I would say it crosses the y-axis, where x equals 0. So if I set x to 0, that first bracket will be 2 squared, because 0 plus 2 all squared, 4 squared. Y minus 3 all squared, 25. And then, oh, I just realized my head is in the way, as always. Let's zoom out a little bit again. So, yep, and then you would just expand this out. You'd say 16 plus y minus 3 all squared equals 25. So y minus 3 all squared is going to equal 9. Y minus 3, you're going to have two solutions. It's going to be plus minus 9. And then y is going to be 3 plus or minus 9. So it's going to either be 12 or it will be 6. Oh, minus 6. So that one up here will be 12 and this one down here will be minus 6. And you could do the same for the x. However, that would be like a harder, higher level question. This one here will be more draw the circle, label the radius. But that's how you do it if anyone is interested. So let's go on to do some more questions over here. So this is taken from an actual exam sheet. So is that solving the square on the right? Oh, I can quickly go back to the right working. So it's very similar to solving the square. The working out here is basically the same as if I was solving the square, you know, that plus minus. It's really just saying that whenever I square root a number, I'll always get two solutions. But otherwise, it's just solving an equation like normal algebra. It just happens that the way you do completing the square, the algebra for that ends up looking pretty much the same because you'll always also get these square brackets. And it's a really good question though. So yeah, it's very, very similar. And this whole plus minus is pretty much the same. Yeah. Let's go over to here though. Let's have a look at another question. So C is a circle with center the origin. So here they've not given us the equation, but they've told us where the center is. So the origin means that our center is at 0, 0. A tangent to C passes through the points -20, 0, and 0, 10. Work out the equation of C, and you must show all your working. So this time we have the tangent and we have a circle. So we have something that looks like, here's our circle, and we don't necessarily know what direction tangent is going to be in, but as x is increasing, y is increasing, so it should be this sort of direction, roughly like that. Gradient equals 2. Okay, good, you're well ahead of me. So good, you're doing the right thing. So we've got two things going on here. First of all, they're trying to get us to work out the equation of C, and C is the circle. So for C, what we want to end up with is our y minus, oh wait, let's go back to the, oh no, sorry. Okay, I was trying to do it so we had it with the way we wrote it before. So our equation for a general equation for a circle will be x minus a all squared plus y minus b all squared equals the radius squared. And we already now know what the center is. They tell us the center is the origin, which means this equation, we can change it so that a and b equals 0. So it's going to be x squared plus y squared equals r squared. And let's zoom out again. So this is what we know so far. And we're going to have to use the tangent to work out what r is, because that's the only thing we don't know in our equation that we need to. X's and y's are going to stay in there. The radius needs to be a number. So to do that, we first of all need to find, and imagine if we have our axes like this, and we have our center of the circle over here. And this, by the way, was one of the harder questions, just to be clear. So this would be a 5-mark question. It was from the end of a Ed Excel paper. So this one is one of the harder questions you would see. So we've got the center of the circle here in the axes. So the radius of this circle is actually going to be the same as where it either crosses the x-axis or the y-axis. And also, we can see from here it's going to be the same as the distance to the point where it touches the tangent. So they're the things to bear in mind. We have different radius points on there. We have the tangent. So if we can find that point where the tangent touches the circle, we can use that to find what the radius is. So this is combining lots and lots of different topics and lots of different ideas. But it all comes from this equation of the circle. So we'll have a start of this. To do this, we first of all need to, let's go back to the question. So we need to find out our equation of the tangent. So the tangent down here, tangent is just a straight line, so that's going to follow the y equals mx plus c. So we'll do that first. So m is our gradient. We have 2 points so far. Let's go down. So, oh, sorry, let's go back to the points. The points were -20, 0 and 0, 10. So, and 0, 10. Okay, so we have these 2 points. We can find what m equals. That's going to be the change in y over the change in x. So change in y is going to be 10 minus 0, over 0 minus -20. So change in y over change in x. which is going to be 10 over 20, which is a half. So Finn, when you were doing the gradient, you just wanted to do your fraction the other way around. Make sure it was the change in y's over the changes in x. So that's first of all. So why is it so funny, my screen? Okay, so that's our first step. Oh no, everything's going to pieces. And then we can sub in to find where our, oh no, my screen has gone funny. Sorry, 1 second. Yeah, so now we can find out also where we've got our y-intercept for this. However, for this one, it's a bit easier because we have some coordinates here of 0, 10. So x is already 0 there, which means that has to be our y-intercept. In other words, on our axis, 0, 10 would be on the y-axis over here. So c is just going to equal 10. And then you can say that y is going to be a half x plus c, which is 10. Is everyone happy with that? Does anyone have any questions with what we've done there? So what we want to do is we want to find where our tangent is going to be crossing the circle. So what we can do is use our diagram. Why is this? Oh, I'm so sorry. I've got everything keeps moving on my page. Sorry, I've got my iPad set up and then it's just not wanting to do it. So, okay, there we go. So we've got our equation of the tangent over here. So now we have a think about how this connects to our circle. So we want to connect this to the radius of our circle. So yeah, great arrangement today, not so well organized on here. So we have our circle like this. It's connecting up to the tangent like so. So what we can say is that our radius is going to be perpendicular to the radius of the circle. Because just by definition, when we draw a tangent on there, it's perpendicular. So what that means is that our radius, or r, is going to be where y equals minus 2, because it's going to be the negative reciprocal, if you think of your equations of lines, x. Just by the definition of where our radius is and the fact that it's perpendicular. So now we've got that, we can actually put this all together now, and it should be much simpler now to figure out what our radius is. So if we go onto the new page, we can say that our radius was 2x, and we have to find where that is equal to our circle, which was a half x plus 10, and now we just rearrange. So we times everything through by 2, so we get 4x equals x plus 20. We can rearrange this so that we get 3x, and minus signs here, so minus 5x, equals 20. And therefore, our x is going to be minus 4. And then we can put that back into our equation for y equals minus 2x. So y equals minus 8. So they are the coordinates of the point where we cross the circle. And then we just use Pythagoras to find the length of that. So if we have our axes here, we have minus 2 and plus 8. Sorry, I'm trying to rush over here. So this is 8, this is minus 2. So you do 8 squared plus 2 squared, square root of all of that, which will be 64. No, I've got myself all in a muddle. Sorry, 4 squared. So it'll be 64 plus 16, which is the square root of 80. And then we go back to our equation of the circle, which is really the key thing here, which was x squared plus y squared equals 80, because it's the square of this. Sorry, I was trying to rush that, but I'll really quickly recap everything we do here. So we go back to the part before, which is over here. This all starts from writing out what we already know about the equation of the circle, saying that we know that the tangent hits the circle over here, finding the equation of that tangent, finding the equation of the radius, and then saying they cross over at that point, and using that to find the length of the radius to put back into our equation. So this was this is like the hardest example you will see on this. But really what I want everyone to take away is what the equation of the circle is, how you read off the center, how you read off the radius, and then putting everything together for yourself afterwards if you have these harder questions, and just going step by step about figuring out what you know and what you need to know afterwards. Yeah, sorry, I realized I rushed through that question. It took longer than I expected. I hope everyone was following, and I hope you all found that useful. Does anyone have any questions before we finish? No? Okay, great. Yeah, we'll kind of carry on with circles next week. So if you found this useful, come back next week. We'll do a little bit more. No worries. Thank you all for being here. It's lovely to see some familiar names as always. And hopefully see you all next week. Have a lovely week. And make sure to watch some of the other revision sessions as well for computer science and chemistry. I will see you next week. Bye. If I can figure out how to get my screen going. There we go.